Here's the presentation.
All right, and we are recording. Welcome everyone to another Integration Quest MuleSoft study group. Glad to have everyone here today. Today we have Sravan Narella. He's going to be going over agent to agent and has an awesome demo. We've seen a sneak peek to it and let's do it. So I've got a couple things to share and show really quick, and then I'm going to turn it over to him. The first thing that we just have to go over real quick. If your mom and dad didn't want you to say or do it, please don't do it. We haven't had any issues for a really long time. So thankful. And we'll just keep going with that. Doing good. Want to share with you all really quick, just in case you ever miss a study group, we've got the library. You can go to the library, go down there to the Integration Quest website. You can check it out. Also at YouTube directly by those two links down there. And you can see any of these videos archived. We've got them all out there for you to check out. Hey, while you're there, drop a comment because I do check those and I communicate with some people back and forth every now and then. It's really cool. So I'd love to see you over there and have a conversation with you over there too. So today, like I said, we have Sravan Narella. He has been doing MuleSoft Architect and he's a top MuleSoft mentor. Not only I like to go over the experience that everybody has. Not only does he have the experience, he's got 10 plus years in development doing Java, JavaScript, but check out this, the most wonderful aspect of anybody that we have on in these groups is that he's willing to give back. He's willing to contribute. He's willing to share. And I'm not just putting that on screen. Like I've literally seen that, and his willingness to be here today has proven that. So I really appreciate Sravan being here today. If y'all can, just give him a warm welcome. Thank you for being here. I'm going to stop presenting so that way he can go ahead and share with us what he's got to share, and we're going to take this in. I'm looking forward to it.
Thank you very much for the great introduction, actually, RJ.
You're welcome, man.
Yeah, one
You
second.
you're fine. So you go ahead and take it over. Madonna, thank you for coming. Glad to see you again.
Hey guys, happy to be here.
Thank you. Great. All right. Yeah, you're sharing. I see you on screen there. Looking good.
All right, perfect. So I hope, yeah, that looks good. Let me just check. I'm going to move my screen. Okay, that's good. That's really good. All right. So hi, everyone. My name is Sravan Kumar Nerala. So today we're going to, before jumping into the topic, first of all, I want to ask a quick question. Everyone is using agents these days, right? I'm pretty sure like everyone's saying like, hey, you know what? I'm going to ask a question to a particular chatbot. I'm going to get an answer, right? And then basically now we're also doing like a lot of things with ChatGPT as well as Claude and as well as so many other LLMs out there, right? So here's my quick question for everyone. Why are we building these agents? And how do these agents actually work? This is one of the key concepts that I was actually pondering for a while. You know, over the past few years, we have this huge spike in AI industry and AI adoption in the organizations. And it all started with a very, very simple thing. You're within an LLM, you kind of ask a question and it kind of answers back. And initially, it used to be like a glorified FAQ per se. You can ask a question, particularly like saying that, "Hey, where is my order?" And it used to be able to return that particular set of information, but it was not context aware at that point. But eventually what happened was LLMs got smarter, and we are able to provide a right context to the right set of tools and everything to the agents or our bots or our LLMs, and they're able to do much bigger things, and they're able to take actions and everything as such. This was like, it's getting very powerful over the period of time. So from a simple response chatbots, we have turned them into an autonomous agents, an agent that kind of takes care of performing a particular action and kind of come back with a particular solution for us. This is really cool, right? So today what I wanted to do is I want to just step back a bit, and then we're just going to talk about like how these agents work and how we can actually build one. And I'm going to specifically focus heavily on the MuleSoft section part of this, but of course you can actually build the whole thing in other programming languages too. Okay. By the way, if I'm looking at the odd places, I have like 3 different monitors up here, so I'm really sorry about it. That being said, a quick introduction for myself. I'm Sravan Kumar Nerala. I'm an integration architect at K2 Partnering Solutions. I'm also a MuleSoft practice lead and heavily AI enthusiast. I have been like following AI for like a past 2 years now, from the day the OpenAI actually released their GPT-2 model. I had my own model running, and burnt a lot of money too. So, but still, I'm a strong enthusiast of it. And not only that, I'm also a top MuleSoft mentor of 2025. And a few days back, I got a confirmation that I'm also a MuleSoft meetup leader. Thank you, thank you for all. Thank you for the MuleSoft community and everyone who actually gave me that role. Thank you. That being said, so let's start off with the agenda for today. So today we are just going to talk about what are agents, what is agent to agent, how does it actually work, and then we're going to see in a very high level how does this actually look on a demo perspective, and then we're going to look into the low level, checking like how we can actually build this in MuleSoft, and then I'll take in a lot of questions. One quick thing to point out, I like these sessions to be interactive. If at any point of time anyone has any questions, feel free to like send out a message, and RJ or anyone can actually like pause me and I can actually take the question accordingly. Okay. Um, that being said, let's start off with the first question. What are agents? Well, everyone defines agents differently. Essentially, what it's doing is it's kind of completing a task, right? So what how this task is being completed is what the agent is kind of like defined as. Typically, like these agents can be completing tasks in a different manners. The first one is like prompting manner, meaning like I can ask the agent, hey, you know what, I want to perform this particular I want to perform this particular action, I want to do this particular step, do it. I'm kind of prompting it, saying that, hey, do this, do this, do this. And this is a way of telling the agent to what needs to happen. And this is kind of called as chaining. The second thing that we can actually provide is something called instructions. It's pretty straightforward as, hey, you know what, instead of me providing all the things step by step, I will just give you as one single set of instructions at once. And you can actually go through all the things, and then you can come back to me saying that whether you're able to complete or not. Then there is the persona. This is a very key aspect of your agent. This is literally telling you like how your agent is supposed to respond to a particular set of actions that it's performing. Is it supposed to be helpful, or is it supposed to be technical, or is it supposed to be like a very simple plain human language responder? Possibly, right? So all of these agents, in order to complete something, first of all, what they need to do is they need to understand the task. What is the task that was provided to me? What is the prompt that's provided to me? And how am I supposed to plan things for it? That's a very key aspect of the whole process. The second thing is, whenever I'm coming with some kind of a plan, I also need to have a proper reasoning towards why am I doing that particular step. Then followed by, I also have to make some kind of an actions, meaning like, do I have to make an action call, meaning like I have to make an API call, or supposed to I have to make some kind of CLI call, anything as such. All of these things are very crucial. And finally, the very important part, reflection. Whether your AI agent is able to successfully complete a particular task or not. This is a very key aspect of the whole thing. In this whole demo or in this whole presentation, we're going to heavily focus on something called React agents. Re and act. Re stands for like reasoning, act is for making an action. Okay. So in this React agents, we're going to focus on three main elements part of it. One of them is the memory. Whatever is happening within your actions or whatever is happening part of your process, we're going to store it somewhere so that people can actually say like, sorry, the agent can actually come back and check, okay, did I perform this action or not? And details as such. The second one is the LLM. This is the brain of the whole operation. It is kind of telling like whether this is successful or this is failure or whatever it is. And finally, tools. These are the actions. These actions are like basically like an API call, or it could be like a CLI action or a terminal command, or it could be anything else. All of these things, these tools are kind of built on something called model context protocol, or they can also be built in other languages too. I mean, other things too, like UTCP, but that's a whole different story. So, and one more key thing that I want to point out, there was this amazing article from Anthropic. They kind of clearly defined it's the article name is Building Effective Agents. One of the key aspects from there is we need the LLM to decide the fate of what needs to happen to complete a task rather than predefining it. What this really means is don't define your steps, meaning like don't tell your agent to do this and every single step of the way. Do not define a workflow. Give the tools to the agent and let it figure it out what happens. And that means what happens is when you give a small task, it will try to make mistakes, but it will learn. But when you give a bigger task now, when it actually learned this all information, when it's kind of coming back to the problem, it knows how to solve that problem. And that's exactly what they're kind of letting you do. And here's the thing, don't build agents because you can build an agent because it can solve something. Okay, don't make it so simple. Okay. um let me give a quick pause up here, and I'm going to ask questions. Any questions so far?
I've been watching the chat. I don't have anything in there. Nobody's asking anything. We're looking good.
Sounds good. All right, that means the next step. So now that we have seen what's in agent and what are the tools in it, let's see how in a workflow how it actually looks. So on a workflow, what happens is the user will always provide a prompt saying like, hey, I want to do something. And that sorry, I apologize. Was it a question?
Was somebody asking something? I'm checking. I don't know. It was Nassar. He may not be muted.
Okay. All right, no problem. All right, coming back. So when a user actually provides some kind of a query, right, it's kind of like a task for an agent. This is the final goal of the agent to complete, right? In order to do this, what we do is we pass this task to an LLM, asking it, hey, why don't you plan me a steps? What are the things that I need to do for this step? Okay. And it's going to provide me a step saying that, hey, okay, these are the steps that you need to perform. And then we're going to take each one of the step, and then we go into something called the tool execution. This is nothing but making an API call or triggering a particular CLI action or a terminal or some kind of particular action. And then whatever the response that we're getting from this tool, we take it and then basically provide it to the LLM back again. And now we are asking a separate agent, sorry, a separate LLM to say that, hey, here is my response and here is my task. Evaluate both the responses and tell me whether I'm successful or I'm a failure. Is the task successful or a failure? And here is the next thing: is that if the task is successful, do I have any additional steps as part of it? Right. So all of these things will be part of my analyze. And once the analysis is complete, I'm going to do a check. Is my task done? If it's done, great. I'm going to send back a response and I'm going to call it a day. Now, here's my problem. If it's not, then I need to add this information to my memory, to my agent's memory, so that what happens is the agent knows like, okay, whenever I'm doing this particular step, this is what happened in the previous step. So next time I'm planning for something, I'm going to pass that information as a memory to my LLM. It's going to make a new plan and it's going to say like, okay, now that I have this new plan of information, I'm going to take it, I'm going to do the execution again, I'm going to do the analysis, and I'm going to do this in a loop until it kind of completes it. And this is the reason why we are calling it as a react agent. So we are reasoning, we are bringing a reasoning up here, and then we are acting on that particular reasoning, and then we are doing the analysis, and then we're going back to the whole process again. Any questions so far?
Yeah, so here I see a memory as a separate entity over there on the top of LLM.
Mhm.
Is it a part of LLM or are we adding a something extra layer over there?
Good question. So memory could be like it's basically like in this case, I'm kind of think if in the MuleSoft perspective, think of it like an object store, but
Mhm.
it could be like a database for other scenarios, right?
Right.
Or it could be in memory, or it could be like a persistent storage too. It could be anything in this case.
Okay.
So as part of the agent, we added this memory because it can keep track of what really happened and come back to what happens next. I
Got
hope
it.
that answers the question.
Yes.
But technically, it's not part of the LLM's memory. We are kind of
Okay.
keeping it separate.
Got it.
Okay.
Thank you.
Yeah. That also brings one more thing. I always like to keep memory as a separate entity by itself, because at any point of time I want to refresh everything. I don't want any kind of memory. That's a pluggable, like a USB thing for me. So I can actually use it, or I don't want to use it, or I can create a new memory as needed.
Got it. And it's easier to refresh.
True. Um, all right. Any other questions?
Yeah, I have one.
Yes.
So for the LLM, between
Mhm.
planning and analyze,
Mhm.
do we usually select two different LLMs?
We can use two separate LLMs, or we can use the same LLM too. Again, for the understanding purpose, I kind of separated these two. These are two separate steps. So, for example, I could say like the planning can be handled through my GPT, or the analysis can be done by my Gemini. per
Mhm.
se, right? Or it could be like different. It could use the same LLMs too.
Mhm.
It should not make a difference.
Okay.
Yeah, great questions actually. Um, are we good? Can I move on to the next step?
Yes.
Yeah, looking
All right.
good. I'm not seeing anything. Thank you for answering those.
All right. So now we are going to see this in action. So let's say that I've built something like a Slack agent, and let's see how this whole thing actually works out, right? So let's say that a user were to say something like send hi to Shravan Nerala. This is a simple prompt. And what happens is this is my task to my agent, and the agent says like, okay, what am I supposed to do here? I have to send hi to Shravan Nerala. So when I kind of provide this information to my LLM to actually like understand and come up with a plan, what it needs to understand is what am I supposed to do? Who am I supposed to send this message? And what is the message? Here are the key attributes it needs to identify. And not only that, whenever I'm providing some kind of a name, the name could be a username or it could be an actual name of the person. It could be either of them, right? So it needs to understand these steps and then followed by come up with a plan. And that's exactly the LLM is doing. It kind of goes through and provides a step one, saying that, hey, what's the username of Sravan Airline Slack? And then it's also asking like the second step would be like once identified, send a message to that particular ID. Whatever the steps that I have now, I will take it in and then basically I'll go into the tool execution. Meaning like in this case, I have a Slack MCP server created. In the MCP, it is already providing the tools, the necessary tools to actually get this information for me. So the LLM is going to trigger my tool execution and then basically provide the information that I need. Meaning like whenever it's making an API call, get information of Sravan Nerala in Slack. And then basically it will provide us a username. It will take that information. Now I have the information of the user. I will take it and I'm going to provide it to my analyze. It will say, is the tool call successful? Yes or no. If it is yes, great. Does it return the required information that I need? If it is a yes, great. Now, is my task done? No, because I haven't sent my message yet. So what happens is the task done? No, it will add that information to my memory. No, in the first step of the process, I don't have the memory of what's the username of Shravan Nerala. But when I'm coming to the step two now, what happens is now I have the information of Shravan Nerala's ID. Once identify, send a message to that ID. You see that? Now it goes into the tool execution again, and now it kind of sends out that message. And once that's done, it's going to check the tool call again, check the response, what is it, and then saying like, okay, yes, this is looking correct. And then followed by, it's going to check, is the task complete? If the answer is yes, we send back a response and we're going to stop the process. But here is a quick thing that I want to point out. There is this a possibility your agent could always go into this infinite loop up here. Okay, meaning like your LLM could be making a mistake, or it could be your planning could be wrong, or anything as such. And this is the reason why we prevent your agent to go making like an enormous number of calls. If you were to use something like a Cursor or GitHub Copilot or Claude, anything, they have this tool number of tool calls that they kind of enable you, meaning like 10, 20, no more than that. After 20, it will stop you and say like, you know what, do you still want to continue, yes or no, right? And if you at any point of time you kind of feel like it's kind of doing unnecessary steps, you can always click on cancel or stop it. And that's exactly the exit criteria of the whole thing. Okay. Questions?
Um, I'm not sure if this question is applicable, but just checking. I was reading through this agent's documentation, and somewhere have read like the LLMs can go to hallucinations as well. So
True.
how do we identify which is the valid information, because it might give us the wrong information as well?
True. That's a very good question. So hallucinations is basically like it's kind of very common with LLMs, right? So when it actually happens, the analyze command is the one which kind of takes care. So the planning part, it's kind of having the memory of what really is happening every single time. But my analyze is the one which is actually like it's kind of a standalone step. Its main responsibility is to understand this. Is it hallucinating or is it kind of making the right calls? Is it not doing the right calls? Any of these things go under my analyze to do this. Let's say the both your LLMs are kind of doing this hallucinations at the time. I would recommend you to pick a stronger LLM at this moment. Um, or increase your context size or decrease the number of memory that you're actually injecting into your LLM to control this.
Got it. Thank you.
Yeah. Again, feel free to correct me if anyone has any better suggestion for this, please feel free to bring up. So, any other questions?
I don't have a better solution by any means. I'm learning with everybody else, but I was like, looking at that chart, everything that I've ever been told about AI and with AI is that we want to be the humans in the loop. We want to make sure that you're getting the response that you want before it goes out to the customer, the client, whoever, So like in this scenario here, how could you put like a safety measure in there to where you're checking it before it goes out, and just to make sure it's what you wanted before it's at somebody's computer screen, mobile, whatever, like you follow the human in the loop terminology, I'm sure. So how could you that's my only thought, is I would just want to safeguard myself, I guess, and make sure that it's doing what it's supposed to. So that way your two LLMs don't hallucinate, and then somebody's sitting there and they're wondering, why am I getting this message that was probably intended for somebody else? That's just my only thought and kind of a question, I guess.
True. Human in the loop is it's kind of like I think every time we are kind of working with it, working with an agent, there is always a human actually like validating each of the steps. And I kind of feel like it is a very valid way of like controlling the steps and trying to like make sure everything's working fine. Yeah. Hi, Ryan.
Absolutely. Very good. All right.
Yeah.
Thank you, man.
I wanted to jump in on that one, Sravan,
Yes.
because you have your awesome diagram up, which is when we were talking about doing this study group. This was part of the reason I was so excited to have Sravan help us out. You see that there's a step there. It says tool execution. I don't want people to only think of tools as APIs. They can be APIs, but they also could be user interactive steps. Like go send an email to so-and-so, check and see if I have a response. Does the response say I'm allowed to do this? Right. So the agent can be one of the intelligent things the agent can do is determine that it is not authorized to make a move without a human's approval. Right. And then it can use a tool to go ask the human, may I do this, please? Right.
Yes.
Because I don't want you spending my money, for example, without my approval, that kind of thing. So that's what can happen in this loop that Sravan drew. I thought it was beautiful. Great diagram, man.
Oh, thank you.
That's spot on. That's exactly what I was looking for, is just, that way you're the one pushing that button, just before it actually goes out. You're the human in the loop and checking on it. So yeah, good deal.
Thank you, everyone. All right. So now that we know about this agents, one of the things that I want to ask you is, please remember this workflow, okay? Because as we are moving forward, it will be really helpful for everyone, okay? And so now that we have understood this, I'm going to give you a small imagination. Think about it. So right now we already have organizations out there who are actually providing these APIs for everyone. What are APIs? These APIs are actually doing the functionality for us, right? For example, for Slack, it would be like something like, hey, send out a message, gather some information for me, or retrieve me the channel information that are available, or things like that. They're kind of providing you the information that you need. But in order to interact with them, you need to be following their protocols, like HTTP protocol, and then you have to make this call with this HTTP verb and this particular authentication mechanism and everything like that, right? So imagine, what if it's not an API anymore? What if it's an agent? What if this transition actually happens? What if each of your organizations are actually like giving out an agent? So that would be like a human representative actually like communicating with you every single time. So what happens is now you're actually talking to everyone in natural language. Just like your agents are understanding your natural language, you are understanding your natural language, you just ask it and the agent kind of performs it. So if I were to say something like, you know what, I don't know how the whole thing works, but I want to send out a message to Sravan, and he's part of this organization. That's about it. And if I were to give this task to a particular human, whatever he does, what if this whole task can be taken into the agent step? And that's exactly what we are jumping into. That's exactly where we're moving towards. With APIs, we have orchestration, choreography, and all these different mechanisms of how to interact with the other agents and other APIs or other integrations. And we're kind of like creating these workflows, right? Now, think in the same perspective, what if we have like multiple agents, and how do we actually communicate with each one of them, right? And that's exactly where Google came up with this protocol called agent to agent. It's a Google's open protocol. It's kind of saying that this is how your agent needs to communicate with your other agents. Here are the things that you have to make sure. Here are the things that you have to provide to me to tell me that, hey, this is correct. This is how I know it. This is what it does. This is what it's capable of. Here are the things, if I were to provide, it doesn't know what it does, right? And if a task is taking more than enough time, how do I react to those things? All of these things are defined part of this A2A protocol or agent to agent protocol. Here are some keywords that I want you to give you a heads up on: agent card and location, task, artifact, part. Artifact, whenever I'm mentioning this is the output of your agent. Part is basically like the input of your user, whatever the user is provided to you. Okay. And remember this, your user is the one who's going to be interacting with your agent, and the agent will be communicating with your other agents. Okay. So, excuse me. So let's start off with the concept of agent card. So what is this agent card? Agent card is nothing but a digital ID of what it is. It's like our driver license per se. It's kind of telling like what's your name, what is your description, meaning like what are the who built you or whatever the details that you want to provide about it. The next thing is the location. Where am I located? If someone wants to provide a task to me, how do I locate that particular location? That's what we're defining. The third one is the skills. It's about what am I capable of, and then followed by supported formats. Can I accept a text, or can I accept a file, or can I accept like a application slash JSON format text, or a particular way of information, right? And then next one is the authentication. If you want to trigger me, what is the level of authentication that you need to provide? Meaning like, do you support OAuth 2.0, or do you actually have a basic authentication, or you have a different kind of mechanism? What is it? Define that information. And finally, the push notifications and streaming. Push notification is nothing but, let's say that your agent is running on for a very long running task, right? And you can't make your other agent wait for it. In this scenario, this push notifications kind of help you in kind of like notifying you when the task is complete. These are like nothing but like a webhook. Sorry, these are like your webhook calls. Okay, so once you actually trigger your agent, what it does is it's going to take the whole information and it's going to say like send back a message saying that here is my confirmation message. I will let you know once the whole thing is complete. And once you're done with it, you will provide a URL, and that URL will be triggered to you automatically. And that's what a push notification is. And you can notice that's actually a true or false statement in this case. The next one is streaming. This is a very, very simple thing. It's basically like short running process, and you're kind of waiting for the responses to come in as things are happening, right? So I send out a small task, and then basically the agent is performing that actions, and I want to see the actions, events kind of coming back to me, and the responses that's happening in there. Okay. On top of these required fields, the other thing that I want to point out is the provider. The provider is basically like telling you like who built this. This is something that kind of helps you to like in trust in the future perspective. Okay, so who built this and what's their organization URL or details like that, that would really help you point out the key informations. Any questions on this so far?
Yeah, sorry, one question. What is it, the default input mode and default output mode?
So the default input mode is basically like what is the input that you're kind of sending. In this case, I'm providing text / plain messages. That's basically like simple text messages. And if it could be output is also a text message in this case. In some scenarios, it could be a JSON object. And that's where we'll say like, hey, the input mode is like the user will be, the agent will be providing you a JSON object, and you're kind of working based off it. Like,
so the agent would be providing the
JSON object to you. Yeah.
So if it's like A2A, would that be like an agent is providing the other agent with? Okay. And then what are the different options? Like, is it the meme type, or is it like something else?
Currently, I've seen text and JSON right now so far, and there is also a file, but I didn't application slash like a form URL encoded one, but I'm not sure if that actually works. Personally, I didn't get a chance to try that out, but that's a good question. But for now, I know for sure the text and as well as the JSON actually works.
Mm-hmm.
Yeah, I'm really not sure about the other ones, but yeah, that's something that I will actually like explore later, and I'll get back to you.
I'm checking right now, by the way. I'll put it in the
Yeah,
chat.
yeah. Thank you, Ryan.
So if an agent has like multiple actions and you want to call specific action, would
Mhm.
would that be like, say every action has a different, input mode or output mode? Is that where you would specify this, or this is more on the agent card level still? We haven't gotten into actions yet.
We haven't jumped into the actions yet. This is on a very high level of what your agent can do.
Sure.
What is the supported accepted parameters or accepted input modes in this case?
Got it. Okay.
Okay. Now that we have okay, before we go, any other questions? All right. So now that we have defined what an agent card is, so we need to host it somewhere, right? So what A2A says is like, you know what, take this agent, and then basically what you're going to do is host this agent card on a particular URL, and that URL is dot well hyphen known slash agent hyphen card dot JSON, and this is agent hyphen card dot JSON. Okay, and in that JSON is what you will have your the agent card. Okay, I will show you a quick example later, and we can show I can show you like how that actually looks. Okay, any questions on that? All right. So the next thing here, we're going to talk about communication, how the agent is going to talk to the other agent. The agent to agent actually works on HTTP and JSON RPC method. And now there is also support for gRPC as well. Okay. So what is this RPC? This is just like your REST, but this is much different. This is more of like a remote procedure calls. What you're doing is you're kind of providing an action, what is the information that you have, and this information will be sent out to your agent to actually process that information. A2A kind of has a specific set of actions here defined. The first one is basically message slash send. This is it's doing is sending a message to your agent. I'm going to show you like how that actual payload looks like in the next slide, but for now, on a high level, just understand that whenever you send something like a message slash send, it's kind of sending a message to your agent. The second one is message slash stream. This is where you're enabling a streaming mechanism between you and your agent. Third one, tasks. What are the existing tasks that your agent is actually working on? List task. This is kind of like telling what are the tasks that are available. And then we can also cancel them, resubscribe to a particular task, and get a stream response. And then followed by push notifications. You can actually like set a configuration saying that, you know what, I want to listen once the task is complete, I want you to send out a web call to this particular URL. You can define that information part of this push notification config slash set. And a similar way, get, and then list, delete, and finally we have the authenticated agent card. So sometimes you can actually like keep your agent secure, and that's exactly what it's doing. Any questions on this? Again, there are like so many other things in there, but these are the main ones that I want to point out here. All right, here is a sample payload or a request, how it will look like. So when your agent is kind of sending out a message to your other agent, it will define a JSON RPC version, and then followed by the ID of your task. What's the method that you're doing? What are the parameters that you need to send? Like inside this case, we are sending out the message, defining the role, who sent this information, the user, and then what kind of message did they send it to you? The kind is here is a text, right? And then followed by what is the message that they have sent. Create a repository named agent repo and send a confirmation message to Sravan using Slack. So this is a kind of a task where we are defining like the whole thing up here. So the whole input message captured the information of who sent it, what is the information that they have sent, and what format of the information that they have sent. Okay. And here's the cool thing. when you're actually working with these things, the kind is kind of a very, very interesting part. It's not restricted to the text. You can also upload files, and then it will actually respond to you accordingly. Cool, right? Uh, any questions?
No new questions, but an old question did get answered by Ryan in the chat if you wanted to check that out. I don't know if
Sure.
that was on your mind or not. It was about the MIME types.
Input and output MIME types for an A2A agent card are meant to be customizable from the spec. Default set of supported input MIME types for all skills, which can be overridden as per the skill basis. Huh. Interesting. So for each skill, you can actually define your own MIME type, and it gets overridden. Cool. Ooh. Yeah, I think that's really cool. Actually, I'll check it out later. That's something I have to play with. All right. Thank you, Ryan, by the way. All right. Are we good for next slide? Okay. I'll take that as yes. Okay. I know I've been a bit technical in the past 2 slides. Let's go back to the design. Let's go back to how the agent to agent actually works. Meaning like the diagrams. So here's the interesting thing. The user is going to provide a task, again, the prompt, and the prompt will be a task essentially, and this prompt will be sent out to your A2A client. Your A2A client is nothing but it's kind of taking this information and it's kind of trying to understand what it needs to do with it. Because all of your agents are now connected to your A2A client. Okay. This is how the A2A protocol kind of dictates at this moment. Okay, so connect your agents to your client, and then basically the client will make a decision towards like which one to call, and then basically make that call accordingly. So if I would if when the prompt comes in, the A2A client will do the exact thing as an agent does, meaning like it's going to do its part of planning, it's going to do its part of like due diligence, and it's going to trigger the information, and it's going to do the coordination and everything as such. Okay, and once the task is complete, it's going to come back and it's going to do the analysis, and it's going to go back to the same exact process as we have seen in the previous steps. Any questions?
No questions. Still just looking great chart, by the way. Excellent work.
All right.
And my question is, can that task done down there in the bottom right-hand corner, could that be the human in the loop? Like, could that be my same concern? You know, I just want to make sure that everything's looking good before it goes out. Could that be me in this scenario? And
yes. Yes.
I think, yeah, we know the answer. Yes.
You can
So
always
just
set that up. Yes.
just wanted to bring it to
No,
light.
no, the answer is
Yeah,
no.
Ryan's like, no, you can't.
It's not.
No,
it's gonna send
That
all the
loop
money.
is okay. So the A2A client is gonna send it's looping itself and deciding if its task is done, and only
Right.
when it's done it sends a response to the human. So
Right.
the step where you can have it go to ask another human would be an MCP invocation. It would not be an A2A.
Right.
This is the loop where the agent is choosing whether it's done with its part next. Like now in that loop, it on the other diagram, it can go ask something and say, well, I've sent an email to RJ, I'm done now. But that
Right.
task done is chosen by the LLM, not by the user.
And that's what I like about this. I just wanted to shed light on that and kind of point that out to everybody. Yeah, that's
so
awesome. That's what I prefer.
sorry, let me here's my thought on this A2A protocol. So based on RG's question, my assumption is can a human be in this loop of this whole process? And I always think yes, they can, because when the A2A client kind of performs its first set of actions and it comes to this analyze section, I can also have a human in loop section up here, meaning like I can actually like send out an email like what you mentioned, Ryan, and then ask you to like say like, hey, this is looking correct, do you want me to proceed to the next step? Click on next, and then basically like it goes on to the next step. But here's the thing, the thing is like this A2A client can trigger these agents not only one at a time, it could be running in parallel too, right? So there's always the ability that you can actually enable a human in loop to get that working. Okay, and what Ryan said is also perfectly true. typically when we're talking about this human in loop, this is something that we're kind of talking as part of the MCP tool or some kind of a tooling in between. Okay. Um, any
Maxim is
Yes.
asking a question in the chat. So Maxim is in the chat asking, he clarifies, he says, I know this is about A2A, but when would I opt for an A2A versus MCP when building an agentic enterprise? That's a good question. Because we did mention MCP, so you were okay to ask that anyway, Maxim.
Yeah.
Great question.
Actually, this is not versus. This is basically like they complement each other. A2A and MCP complement each other. Here, if you are to notice, the A2A is kind of talking about how the agent needs to communicate with other agents. But MCP is kind of defining like how you're supposed to trigger your calls, trigger your actual tools, and then basically providing that access to your LLM. It's kind of streamlining your information, like how these tools get access to your agent. That's it. But they both can be complemented. They both are complementing each other. They're not versing. I mean, they're not fighting with each other. I hope that answers the question. And especially when you're thinking in the agentic enterprise, um, I think your A2A is going to be a big thing in there, because you will have all of your agents registered somewhere, and then basically like you have to make sure you're actually, you know what? Let me jump on to the next slide, and maybe it will make more sense as we move forward. Okay. So now we're going to jump into the concept of orchestrator. So orchestrator is nothing but same thing as like what we have seen in the previous integration concepts. Its main responsibility is to coordinate and collaborate. That's it. But here's the thing: when this orchestrator actually receives some kind of a task, what we're trying to do is I want it to understand the task. What is happening? What is the user request? Understand it. And then followed by it needs to do something called agent registry. This is where all my agents are registered. It will make sure to check all my agents that are available, and then followed by it needs to make an informed decision towards whether I'm able to complete this task or not. Then followed by it needs to identify the agents that who can actually do it and what are the tasks that I need to create, like a planning state. Then followed by we have to talk about some kind of a context and memory sharing, meaning like whenever I'm kind of sending a particular prompt from one location to another location, I need to provide a right set of information to what happened to the previous step. So far, what happened and what are the information that you need to move on to the next step. And then followed by what we're going to do is we're going to assign it. The orchestrator is going to assign this task to that agent and it's going to send it out. It could be either running in synchronous way or it could be running in a parallel way. And either way, it needs to follow up and it needs to coordinate. Once all the information is ready, it needs to reflect on action. Okay. So if you were to look at the diagram on the right, it's basically like your orchestrator is kind of communicating with all of your agents and it's kind of working with all the tools up here. The same exact way. Now, if I were to point this in an actual workflow, this is how it looks. There is a prompt, right? The user provides a prompt, and this is going to be sent out to my client. Now, the client's responsibility is been like cut down by so much. Its own responsibility is to like send the message to the orchestrator agent, and the orchestrator agent will take care of identifying the task, understanding the task, breaking the task, planning it, and then basically sending out the task to each single agent. And notice here an interesting thing: an agent can also be pointed to another orchestrator. And basically, like you can wait for it, or you can actually continue based off how you want this whole agents to be configured and worked. And all the information will be will be performed in the same way as our actual agent workflow works. Meaning, like the agent will actually plan it, it will execute each one of the step, and then once it's done, it's going to come back and analyze the step, and then basically it's going to check, is the task done? Yes, great. If not, we're going to go back to the memory, and then we're going to say the orchestrator, I think the task is not done. Do you need to assign it to a different agent? Check it out, and then basically make that action, come back, and then we go into this loop until they're successful. Questions? I think I went very fast up there. Sorry.
So the orchestrator can only communicate with another agent or another orchestrator, but not another A2A client, correct? Because
it can be. Up here, as we can see, the A2A client is also communicating with your orchestrator agent. Essentially, this is still an agent.
But would would you be able, so would an orchestrator be able to communicate to another A2A client that has an orchestrator
Another A2A client? I
or
don't
no?
think so. I don't think so. No, I'm not sure.
Because A2A client really is just the user would be able to communicate with an A2A client, right?
Yes.
Got it.
User communicates to the orchestrate, I mean, the client, and the client sends it to the orchestrator in this case.
Right.
But the orchestrator can send back a response, but not to another client.
No,
Not
it
that
can.
I know of.
I think that's a vocabulary thing. So the word agent is super overloaded, right?
Okay.
So just think of a loop, something running in a loop. It's any program running in a loop. That loop can contain one API client. It could have two A2A clients. It's just a tool, right? The A2A client knows how to call other agents. So an orchestrator agent is an agent who has a special job of calling other agents, and it will use A2A to do that, right? So one of those agents can have its own loop, right? And call more agents, so it's recursive, right? That's totally possible. So A2A is just the connection from something, which is usually an agent instead of a human, to another agent, right? It's a protocol for that. And it can be that agent can itself use A2A, and that agent after that can itself use A2A.
Right.
Yeah.
Thank you, guys.
Yeah, thank you. Actually, I really love the questions that are coming in, actually. Thank you, Ryan, for supporting me on this. All right. So jump on to the next step. Are we good?
Yeah, looking good. Thank
All
you
right.
for checking.
So time for demo. So I'm going to show you like three things here. One is like a box agent, meaning like we're just going to look at the agent and how it actually looks, how it's in the implementation look. The second one is an A2A client and the orchestrator. And once that's done, we're gonna see something. I also planned for something, but let's see if time permits. Why not? All right. Yeah, please let me know once you can see my screen. All right. This
We see slides.
I
uh,
see
one second.
demo box agent.
Okay, 1 second. Sorry,
You're fine.
not sure. Okay, I think I've selected the window earlier. Maybe that's why it was acting up. Okay, how about now?
There you go. We have
All
studio
right,
looking good.
perfect. Perfect. Okay, so this is basically like a box agent. In this agent, I have kind of did two things. One, it will be using A2A server or A2A connector for this one. The second one is the MCP tooling, MCP tooling to perform the box calls and everything like that, and then followed by an inference connector. This is a MuleSoft inference connector is the way we actually communicate with our LLMs at the moment. Okay, so here what we have done is when a task actually comes into you, there is a task listener that actually waits there, and once the information comes in, we're going to listen, we're going to capture all the required parameters, and that includes my memory up here. I'm starting to create something called a memory and saying like, hey, you know what, this is what the user has sent me, and here is my part of the information that I have. And once the information is kind of initiated or the task is initiated, it already comes with some set of details, the context ID, the attributes, task ID, and details as such. We are capturing all that details, and then basically like we are moving on to the next step of listing all the tools. What does my box storage actually provides? What are the tools that it provides? I need to know. So what I am doing is I'm using an MCP client, and then I'm saying that list all the tools that the box actually is providing. Gathering all the details, I have converted that into some particular format, saying that hey, here is my tool and this is what it does. Tool name, tool description, and what are the required parameters. Three things. Once I have these three things, what I'm doing next is I'm going into my planning and execute step. The planning and execute step, it's pretty straightforward. I'm passing the tools, whatever I've captured in the previous step, the user provided prompt, and then followed by I'm kind of saying that hey, you are an agent, you're kind of you're a planning agent and you're responsible to do this particular set of actions. And once you're done, I'm going to provide you some kind of instructions towards what needs to be done and what not to be done. And once the whole task is complete, I also want you to return the data in a particular format, and I have defined my JSON object in there. followed by I've provided my data, whatever the data that I wanted to send. Once that is available, I'm going to go through the process of creating a plan, and then I'm going to check. The very first thing that the plan is also going to do is it's going to analyze the step, and it's going to tell me whether this agent can perform that particular task or not. For example, if I were to come to a planning box agent and I ask it to accidentally send some kind of Slack related information, the box agent should say like, I don't know what you're talking. So that's exactly my planning step is kind of doing there. It comes here and it's kind of defining like whether this is a relevant action that I can do or relevant prompt that I can actually handle. And then basically it goes to the next steps. Up here, it's going to checking, and then basically it goes up here. If it's a invalid, it will stop right there. Otherwise, it will go through the process of executing the steps. Let's assume your task is actually complete at the time it goes into the step of between, and then basically it will summarize what happened so far and sends back a response. And then here is the execution step. This is how the execute actually works. The plan can generate an array of steps. It could be one step or two steps, or it could be multiple. And they can be running in parallel or it could be running in synchronous. It's all defined by the planner based on the dependency of each one of the steps. For example, if I were to ask you to say something like, hey, create a repository and send a message to Sravan saying that, hey, you know what, this ask, whatever you have asked, just complete it. Meaning like I've created a dependency up here. You have to complete the step one to actually send out the step two. So what needs to happen here is it goes into a sequential step. Let's say that I were to ask it to do something like, hey, why don't we create two separate repositories? Repository number one is this one, repository number two is this one. In this case, creating a two different repositories, right, doesn't require to be synchronous in this case. So it could be running in parallel, and that's what we're kind of defining it up here. And we kind of go through the process of in order to trigger our tooling or our tools, we are using the MCP tooling, but MCP tooling provided by the inference connector, and that kind of puts together all the required details and sends the information to the tool, MCP tool, and it kind of completes the process. Once the whole thing is done, it's going to go into something called evaluation. The evaluation is kind of telling like what is the step success or a failure, and then followed by I use the information to go back to the planning state and then come back based off the end logic. Any questions on this?
Madonna's checking, and I am also checking. The screen share stopped, so I don't know if you meant to stop sharing that or not. But we're not
No,
seeing
actually,
studio, right? There you go. You got it back.
okay, I don't know where did we lose, but
it was just maybe like a few seconds. It wasn't long at all. It was
okay.
You had already gone down past the flow reference and we're showing the execution. Yeah. So everything was showing up until just a few seconds ago.
Okay.
Good.
Any questions on this agent? Okay. For the people who are really interested to go through the code and understand further, I've created a link up here. I'm not sure if we share the links, but yeah, I have the link up here. Feel free to take a look into it. Okay. And the next one, we're going to jump into the A2A client. One second. Let me close my repository and let's open the A2A client. Again, this is going to be a very, very simple thing. I'm not doing anything here. All I'm doing up here is I've created a simple API, HTTP endpoint that has /prompt. And whatever the prompt that you're providing to me, I've taken that message and I'm generating a JSON RPC or my A2A response structure, sorry, request structure, and then basically sending it as a task, send message at this moment. And once the task is done, it's going to stop right there. This is a very, very simple send task from the client. I'm hoping not much questions from here, but yeah. All right. So that being said, let's go into the orchestrator. And this is where we're going to have a lot of questions. The first one, what we're going to do is we're going to talk about the agent registry. This is going to be a HTTP endpoints. I've defined a simple API spec saying that, hey, you know what, this is my agent registry. Yeah, agent registry. And then in this agent registry, all it's doing is when someone provides me some kind of a URL, it's going to just grab it, it's going to go and trigger the location and gather the agent card. And once the agent card is received, what I'm doing is I'm storing that information in my object store. Okay. And if I were to delete at any point of time, I have a delete endpoint too, and that kind of deletes the whole thing. That's agent registry, a simple thing. So basically all you're doing is providing your agent location, and it's automatically getting your agent card, and then basically saving that information in my object store. Okay. And that goes into my next part. This is the orchestrator. One second. Excuse me. All right. So just like how you have seen for the box agent, the orchestrator agent is also doing the same set of steps up here. But there is a one step that's additional that the box agent doesn't have. Up here, what it's doing is it's kind of going through its agents. What are the agents that are available part of my registered storage? And then basically using that, I'm going to going through the execution plan. Remember, in my box agent, I was retrieving all my tools. In here, orchestrators tools are nothing but its agents, and we are using that agents up here, and we're going through this execution loop again, the same way as how we are doing the box agent. Any questions?
I don't see any questions on that, but at some point before we get to done completely, we have checked the link for the GitHub, and it's saying that it's not public, so we may have to fix that at some point. It's not. I tried opening it also. It's not allowing anybody in, but that doesn't pertain to what you're doing right at this moment. I just wanted to put that out there before I forget to mention it. So you're good. We'll get that taken care of, Nassar. Thank you for bringing that up, because I hadn't checked the link until you said that.
I need to fix that. I will take a look into it. I apologize. I thought I already kind of made that as public, but
no worries, man. You're good. Go ahead.
Cool. All right. So that being said, now that we have seen these things, I have done. We have seen the A2A client, and we have seen the A2A orchestrator, and then the agent, right? So what I'm going to do is I'm going to play a quick demo of what I have done. So this is a simple. I didn't want to do it on screen, so I have recorded the session so I can show it to you how it actually looks. So what I've done is when I was learning the A2A, I wanted to like see how the whole thing actually works in person. So I went into the details and everything. But when I'm showing it to the users, people were like really confused. Okay, what am I doing? What is it really doing? Right? So I said, like, you know what, let's build a small interface so that I can actually tell us like what it's actually doing. So before this is a small agentic UI that I've built. It actually has two things. On your left hand side, you see there is something, this layer icon that's basically like agent registry.
No, we
And
lost the screen again.
oh my god. Okay, sorry. I apologize. I think every time I move my screen from one location to another, it kind of loses it. Possibly. Okay.
Okay, that looks cool.
Okay. All right. Okay. So on your left hand side, whatever you're seeing up here, this layers is basically like your agent registry. You can actually add your agents as you're moving forward. And then basically this is kind of defining like where your orchestrator is kind of working. Okay. There are two configurations that I provided. And all I'm going to do is, as part of this, I'm going to click on start and let it do the whole demo. Here, notice that I'm actually like saying that send hi to Sravan Nerala. This is what I wanted it to do. And once I do that, what it does is it's going to track the message, and as well as it will, on the right hand side, it will tell you like what the execution is happening. The user has sent out message, the orchestrator has done something in there, and then when you click on it, you actually see like what's the message it actually returned, and then basically how many times the Slack agent is being triggered up here. Notice that, and then basically every time it does it, kind of provides the information of what happened. Notice the step there. It says find Slack user ID, and then followed by retrieve the username, and then followed by sending a hi to that user terminal using the retrieve user ID. And once it's done, it's going to say like whether it's a complex task versus not. And then there is the history of what happened as part of the tool. So at any point of time, I want to go back and see like what really happened. Here is my information. Okay, and basically that's the completion of whole tool. And when I click on agent and completed, it says that what really happened in there. All right, and that's the demo of the whole agent, how it actually looks. And here is the UI for that, by the way. Here's the agent registry, and this is how you can actually like register your agents. And here is where you can actually configure your host. Cool. Cool. Good question, actually. So in this case, this is one of the things that I actually ran into. When you have like two separate agents, you have to provide like a clear set of instructions towards what needs to happen. If you're using if Slack and Teams are basically like happen or are kind of like a part of your communication, you need to really tell like what really is happening. If you want to send it through Slack or you want to send it through the Teams. Otherwise, what happens is the orchestrator can make a choice towards like wherever it kind of like tries to find it. Or there is also the other possibility where it can actually make this into two separate actions. Send a message in Slack, send a message in a Teams. Whatever works, it's going to be like a race condition and kind of completes the task. And once the whole thing is done, it will tell us whether it's success or a failure. And sometimes, not sometimes, we can also do one more thing, which is within the orchestrator, we can also request for more information. Meaning like whenever you provide some kind of a vague description saying like, hey, send a message, without providing the right context, like what do you want me to send and who do you want to send? At that time, the orchestrator can actually reject the request saying that, hey, you know what? I need more information. I need input required. And then basically like it's going to send back a response to the A2A client requesting the more information to be sent at once. And once the user provides more information, it will take that information to actually perform the task. I hope that answers a question.
That was a good question, Maxim.
Yeah.
Thank you for asking that. And thank you for coming, Madonna. No worries. Appreciate you coming.
Mm-hmm.
Very good job answering that.
Thank you. All right. That's all I have part of the demo at the moment. But
okay. We'll still let people ask questions. If you want to stop sharing, I'll.
1 second.
Go ahead. You good? You good? Not rushing you along. I was just giving you options.
I think there was an interested party in Agentic.
Thank you.
Do you see, Sravan?
It is, yeah. It's a custom UI that I built. I was kind of, I kind of love building websites and everything. That's my pastime, but I always feel like, we can always build these things much easier. Yeah.
Wonderful.
Yeah.
Very cool.
Very nice. It's exactly how you want it when you make it.
Yeah. Right.
Man, thanks for running the study group this week, Sravan. This was exactly what I was hoping for. You did a great job.
Oh,
seriously, very good job. I'm impressed. Everybody's impressed. Everybody contributed. Everybody asked questions, and I love seeing that. I love seeing the interaction with everybody. Thank you all so much for asking questions through it. I always give an option at the end here to ask questions at the end also. So if anybody wants to come in and ask something, please do so. That is cool. So yeah, so you made that website. You made the Agentic, and it's now anybody can use it, I guess, right?
No. It's not.
Okay.
It's just
not yet. Huh?
For this demo, I kind of built it again. This is something that I said, you know what, I'm going to build this UI. I thought like maybe if non-technical people were to just jump in, they were to look at the Postman collection, they would be like, okay, I don't know what's going on, right?
Yeah.
I want them to like understand, okay, this is what it's doing.
Yeah.
And I have turned the repository to be public now, and I believe everyone should be able to access it.
Okay. If anybody wants to try that, I'll even go check it out myself. Make sure. It's still saying that.
Something, if you're not able to see it, just click on refresh 1 or twice, and you should see it.
I usually have to open like an incognito window too. You got it, Ryan?
I'm
awesome.
in.
Perfect.
That's what we wanted.
Yeah.
Good deal.
I also provided like all the. Oh, I forgot to show the actual agent card, how it actually looks. But that's. But I did provide like the how that actually the whole A2A agent works and everything. So inside the, feel free to go through the README, and you should find the required details in there.
Good.
Yeah.
I'll even put this link in the YouTube video description. So if anybody's watching this in the future, just check the description. You'll have the link right in there.
Sure.
Good deal. Well, if nobody else has any questions, I just want to thank everybody for coming, and I'll hit the stop recording button. We're welcome to hang out and chat some more like we usually do. And thank you again, Sravan. Great job, buddy.
Thank you.
Thumbs
Ari.
up.
So
All
is your now are we done? We off
right.
recording?
Either way, if you want to
Off
be
the recording.
recorded
No,
for
no.
this, okay, I'll stop.
I got chit chat.
Okay, I'm stopping.